Good morning. I am Caroline Troop-Gill. Welcome to this news briefing from the 252nd National Meeting and Exposition of the American Chemical Society in Philadelphia. We're joined today by Dr. Thierry Thomas Danguin from the French National Institute for Agricultural Research. He will be talking to us about a new device that can help improve the taste of foods low in fat, sugar, and salt. Dr. Thomas Danguin?
Okay, so I'm a researcher in France, and I'm working in a National Research Institute, which is the National Institute for Agricultural Research. But I'm working in Dijon, a small town south of Paris, and in a research center which is called the Research Center for Taste and Feeding Behavior. And within my team, which is interested in the molecular interactions, the in-mouth mechanisms, and flavor perception for food, I'm leading a small group, which is the chemosensory interactions and food flavor perception group. And in this group, we are trying to investigate the mechanisms of food flavor integration, meaning that when you taste a food, you have several sensations, which are taste sensation, salty, sweet, but also many smell sensations, like floral or fruity. And all these sensations are merging in our brain to form the overall food image we have. So we are interested in understanding how this food image is constructed within the brain. And this led us to this interesting idea that it is possible to compensate one sensation by another. And it looks like very interesting in terms of compensation for reduction of salt, sugar, and fat in food. Meaning that when you reduce, for example, salt in food, you decrease the saltiness of the food, the salty taste of the food, and you also decrease the liking of this food. And the idea is to play on another sensation, especially the smell sensation, in order to be able to decrease the salt content, or the saltiness per se, but you can modulate the aroma perception so that you maintain the overall salty taste of the food. So that's what we did in several experiments, and we show indeed that some aroma are able to compensate for salt, fat, or sugar reduction in food. And were also interested in the idea that this aroma strategy, which is called the odor-induced saltiness or taste enhancement, can be combined to other strategies that have been proposed or are investigated at the moment around the world for trying to maintain the taste of food, of low salt, sugar, and fat foods. And for example, we combine this odor-induced taste enhancement strategy with a substitution strategy, for example, using potassium chloride instead of sodium chloride in food, but also some other strategies, such as heterogeneous distribution of salt within the food. We did an interesting experiment in which we combine this strategy, which is interesting because you can concentrate, for example, the salt in one part of the product, and then your salty taste is increased. This has been deeply explored and published by colleagues from the Netherlands. And in our lab, we combine this strategy with heterogeneous distribution of aroma within the food. And combining these two strategies, we were able to compensate at a sensory level for a reduction of salt content within the food of 45%. This has been done in model food, of course, in which we can control several parameters, but it looks very interesting in terms of combining strategies. And very recently, we tried to understand what happened at a molecular level. That's why we designed this so-called new device, which is in fact a combination of existing device, in which we are able to pick up some food aroma compounds that are able, for example, to increase the sweetness. And we work on the sweetness dimension of fruit juices. And we were able to find in these fruit juices aroma the compounds that are able to increase the sweetness perception. And when we increase the concentration of this compound within the food, this fruit juice aroma, we were able to see an increase of the sweetness perception. So this is the so-called gas chromatography olfactometry associated taste and olfactoscan technique. And that's why I'm here, and I've presented these results yesterday at the ACS meeting.
Very good. Are there any questions? I would ask that everyone wait for the microphone and state your name and affiliation before asking your question.
Thank you. So it's Kath O'Driscoll from Chemistry and Industry magazine. Could you say what some of these odor chemicals actually are in terms of their chemistry?
They are very classical aroma compounds like esters, which induce like a fruity odor, for example, or floral odor. These are mainly those type of compounds that we see are interesting in terms of increasing the sweetness in this fruit juice.
Are they natural compounds then?
Yes, they are natural compounds because what we did in this device is that we indeed analyzed the real food aroma, and we found these compounds within this aroma. So these fruit juice are 100% fruit juice, so the aroma is natural, and the compounds are within this aroma, so of course they are natural.
How would you actually add those aromas? When, during what stage of the processing or the manufacture of the foods would you actually add those compounds, and would that addition add to the expense of the foods?
This is not easy to answer this question because I'm not part of a food industry. I'm part of academic research, and I don't participate in any food elaboration, so we are just investigating the mechanism. So in our system, we just add at very experimental level the aroma compounds within the food flavor. This is this GCO80 olfactoscan system which is doing that. So it's very experimental, and people are just sitting in a room and smelling what's coming out of like a tube, and they are saying whether the smell, the odor is sweet or not. So this is far away at the moment from real food. So I cannot understand how this is possible to add it in during the food process. This is not my expertise. So.
Can you say something about the actual instrument that you've developed? You mentioned it was, I think, gas chromatography, but what is special about that instrument?
So this instrument is special in the sense that it is a gas chromatography system, quite classical to analyze the food aroma compounds. But at the outlet of the system, you don't have a chemical sensor. Indeed, you have a chemical sensor, but you have also people sitting in front of the end of the chromatographic column, and they are doing what we call olfactometry. That is, that they are trying to describe the odor they perceive when the molecules come from the system during the run of the GC. And this GC outlet is combined with another outlet which come from an olfactometer, and this olfactometer has for aim to deliver the fruit juice aroma, meaning that there is a gas going on the fruit juice liquids which is in a chamber, and then you have this aroma delivered at the end of this olfactometer, and it combines with the molecules coming from the GC. This is the olfactoscan system. And when the people smell the mixture of these two outlets, they have to say whether they perceive it as strongly sweet or not. And this is this new methodology that we use and we were able to pick up the specific compounds that indeed increase at a statistically significant level the sweetness dimension of the aroma.
Thank you.
Doug Dollimore, American Chemical Society. Doctor, one of the things that I was curious about is that the folks who were smelling these aromas were smelling it through a nasal tube. Is that correct?
Yeah.
Yeah. So when people are normally cooking, the aromas are more diffused. and so and a lot of people season their food before they even taste it. So I'm wondering how far away, I mean, is this like a normal aroma that you would smell from like a bowl of soup and it would come up and you would say, it's salty enough?
From the experimental point of view, I would say no, because this is very experimental setup. So this is just to pick up the molecules that are indeed interesting. Afterward, we have to control whether this aroma, which seems to be interesting in the first level of the study, are indeed contributed, for example, to the sweetness of the overall product. So to do so, we just added this compound in real juice, and we ask people to taste the juice in their mouth in our sensory booth, and then it's more realistic for them because they are tasting a real product in which we add these aroma that we want to test, and in that case it's for us a way to confirm that these odorants are indeed contributing to the sweetness of the product. And this is our very last results we obtained. We added these compounds that we picked up with our GC080 olfactoscan system, and some of these compounds were indeed able to increase the sweetness of the juice per se in the sensory conditions. So we are not in real food condition like in a restaurant or at home, but we are more close in our sensory booth because people are indeed tasting real products and not just smelling the aroma of the product. So I hope this answers your question.
Sure. We have another question over here.
Yeah, so we have an online question from Christine Suh, Office of Public Affairs. Do the flavor compounds have any nutritional value?
So flavor compounds means a lot of compounds. So of course, sweet compounds, salty compounds have nutritional value. But as far as the aroma compounds are concerned, the nutritional value is very low, if not inexistent, because the concentration of this aroma within the product is very, very low. It's like, I don't know, yes, very, very low, 1 part per million or 1 part per billion. So the nutritional impact in some is not is more or less
negligible.
Thank you very much.
Okay,
but however, the psychological effect of these compounds, because they are perceived, so you have the psychophysical or the psychophysiological effect of these compounds is not negligible.
You got it. Negligible. Yes.
Okay. Thank you.
Good.
Okay. And there's another question from Christine Suh. Would it be possible to make the compounds so that they can be used like salt and pepper at the table that people would add after the food is prepared?
This is a very interesting question. At the moment, we didn't perform any experiment for like at-home strategies to try to avoid adding too much salt or sugar in the product. But this is, of course, an idea that we have to see how the consumer can also use these kind of strategies, like odor-induced saltiness or taste enhancement, or even heterogeneous distribution of the salt or sugar within the product, but to do it when they cook or when they are ready to eat the product. And we hope to be able to perform some experiments showing that it is also possible in this direction. But of course, chief or even at home when you cook, you are if you are used to use these spices or herbs and so on, you know that some of them are able to increase the flavor, and so that you don't have to add so much sugar or salt. I personally do that when I cook at home, so I think it's a good strategy, but it needs to be confirmed by real scientific research experiments.
I have a couple of questions. Bela Buslig, Office of Public Affairs, ACS. Since your evaluation system involves people for detecting aromas, how do you standardize people? Two people just don't smell the same way or perceive the same smells the same way, and this, since we're in science, we're like reproducibility. So how do you do that without getting into arguments over one guy thinking one thing, the other guy another thing? How do you do that? Because obviously, if we had a machine to do it, that would be the easy thing.
My answer would be this is sensory evaluation.
Right.
And sensory evaluation is, of course, used to this variability. So that's the reason why when we are working with groups of people, and especially in our experiments, we are working with quite a large group of people from 60 to 100. So that this variability is in some way, how do you say that? We take into account this variability, but there is also a consensus between all these people. When you perceive, for example, a lychee odor, everybody is okay to say, okay, it's fruity, it's sweet, which is interesting for us, and so on. So there is a consensus, especially within a culture. From culture to culture, it can be very different, but within a culture, you usually have this consensus. And you have the variability, but the variability is manageable. And we do then statistical analysis to ensure that the results we obtain are indeed significant.
I presume all these people are trained to kind of use standard terminology and standard way of interacting, so you can make it.
Yes and not. It depends. Sometimes you can have very well trained people if you want to do a specific analytical things within our product. Our approach, at least for this kind of study, is quite different. We just ask consumers. And consumers are not trained. They have their personal training, but because they are used to taste food and so on. But we don't train them in a specific way. And of course, the variability increase. But in the end, with a large group of people, you obtained like a main direction for the results. And this is what we are interested in. We are not interested in people like doing very fine analytical sensory evaluation of the product. We want to be at the overall perception of the food or of the aroma, because this is what we want. We want the overall perception and not the taste perception, smell perception, which is interesting in some case, but not in our case. And this is one approach. The other approach is to have people trained, of course, and then they are able to say, okay, the saltiness of this product is like this, the sourness of this product is like this. They are able to analyze every sensory dimension, and they need to be trained to do that. But this is not our aim. Our aim is to have the overall perception of the product.
Now, the other question is, you identify a bunch of these compounds. Would these aroma compounds be possible to be used in a situation where you take a very, very bland, standardized material, perhaps inferior cheeses, let's say, and add enough to it so it will taste like the top brand around? Like, that's a concern. Of adulteration and whatever have you, because if it tastes like it, people won't be able to tell the difference, even though the nutritional value is not anywhere near as you would expect.
I think it's very difficult to reproduce like synthetically the real food, especially in the case of cheese, where you have this fermentation process, which gives you a lot of aroma compounds, very different. Some of them are at a very, very low concentration, but contribute to the overall aroma in a large amount. But working with very, you say, not flavored or unflavored system is what we are doing in our experiment. We are doing a model food system in which we have more or less no flavor, but which resemble the real product, so that we can manipulate and control several parameters, so that we ensure that the only dimension we are making varying is the one that we target. And in this system, this is interesting for researchers, but this is not very interesting for consumers. We can indeed manipulate the flavor, but for consumer, tasting this product is not very interesting. You know, they are more interesting in tasting like complex product, and especially the product that have been obtained through specific traditional process of fermentation, for example, for the cheese or other product, which is there is a flavor richness which is, to my point of view, difficult to obtain with adding flavor compounds during the process. So
Thank you.
That's my point of view.
Good. Thank you. Any further questions? In that case, I'd like to thank you. The archived version of this session will soon be posted at bit.ly/ACS Live Philadelphia. Please join us for our next conference today at 9:30 on a degradable synthetic rubber that could make tires more environmentally friendly. Thank you.